Hello folks, just recording today's quick lecture on shape of distribution and levels of measurement. So the general idea is different distributions have different shapes. Distribution is a group of values that has been organized in some way, and a distribution shapes refer to the pattern of the distributions of its scores, which is how its scores are distributed. And the kind of went over a normal curve in an in-person class already, but we're going to go over it here again. If we did go over frequency last week, and frequency, all that is the count of something. So like, one object, two object, three objects. So as this line increases to the top up here, as it increases in height, the larger the amount of things that you're counting occurs. So let's say that, for example, the peak here represents 10 cartons of milk. Then we could say this is 1, so this will be 1 carton of milk, and so on and so forth. So what we're doing here with distributions and frequencies is we're just counting, okay? So it's a normal distribution in itself is not like an empirical thing, meaning something that we observe in the real world for real, except for a few exceptions, height, weight. Normal curves do occur from that, but they usually require millions and millions of samples. So on the other hand, many approximate it. I did bring up the height and weight conundrum. We take a look at here. This is the normal curve. The mean and the median and the mode are all the same on the median on the normal curve. And we have two tails. We have the lower tail and the upper tail, and we'll talk about the tail as we go forward. Then we have standard deviations above or below the mean. So this is how many standard. So we have the mean right here, as in the normal curve, right? And if it's -1 standard deviation below the mean, then it will fit in this range, as well as +1 above the mean, 2 above the mean, 2 below the mean, so on and so forth. And you can expect standard deviations to hit anywhere on this chart. To rewind a bit, standard deviations are a number that we can calculate and assign to frequency distributions to place a number on the distribution itself. Every number in the distribution, in the frequency distribution, in this case the normal curve, will have its own individual standard deviation, which will approximate its location on that curve. Getting into skews, this is a positive skew, and one of the positive skew is, to rewind back again, a normal distribution has no skew, as if the upper tail and the lower tail are equal. This is a symmetrical curve. Skews are not symmetrical. So skewness refers to the distribution shaped apart from symmetry. The more departure, the greater the skew, and this is a positive skew. So with a positive skew, scores cluster towards the negative end. And how this works is that we can say income is a skew. So, for example, more people are closer towards under 100,000 in the United States than they are millionaires. So we see a income distribution that skews towards the scores will cluster towards the negative end. So, therefore, positive skew, okay? It is an extreme positive skew for income. Again, about 95% of the U.S. population make 100 grand or less, right? And as you move towards $1 million a year, you start seeing less and less people make that. So, these are, the way you tell skew is where the tail is at, right? Recall that the tail is equal on both ends for a normal curve. Well, on this end, the tail is very long, all right, on the positive side. Therefore, this is a positive skew. So the more the tail drags towards the positive, the harder the skew. Negative skew is technically the same thing, except in reverse. So the tail is on the negative end. It hangs out towards the negative end, and then you have, pregnancy gestation is a negative skew where you get most of the time the distribution hits at around 9 months, 8.5 months, something around there, according to the data here on the length of gestation. And you can see the tail start popping out towards the premature birth rate, and sometimes that women will carry 10 months. So the tail kind of hangs out towards the negative end here. Okay, so scores cluster at the positive end for a negative skew, but the tail is on the negative end. So negative skew, negative tail, positive skew, positive tail. This is kurtosis. And kurtosis is the peakedness of a distribution. You can see high kurtosis. So the higher the kurtosis, the sharper the peak. Okay, flat mountaintop is a low kurtosis. Pointed mountaintop is a high kurtosis, and normal is a nice little round mound. So kurtosis is just there's a very big cluster of frequency occurring at the peak of the distribution. Not going to get too much into z-scores. It's here for you if you need it. There's not going to be any assignments on that though, but there's your z-scores. This is more on z-scores. All z-score really is it shows the relative placement of the variable of the not the variable of the number. So let's move into levels of measurement while we're here. So there are 4 types of levels of measurement. You got the nominal, the ordinal, the interval, and the ratio. Let's going to go ahead and break these down. So nominal are variables such as that are not numeric. Your gender, your zip code, your race, your religion, your sex, place of birth, URO code, social security numbers. Those are all nominal variables. Categories of nominals will have to be exhaustive and cover all types of observation made. This is true for everything, honestly. Categories must be mutually exclusive. They can't blend in things. Like you can't include, unless of course you have things like heterochroemia, right, where you have 2 different eye colors. But like the example here being race, because you can make a mixed race category as well. There's no real ordering here, but just make sure if you have a data set that contains race that you list everybody's race is what it means by exhaustiveness, and exclusiveness means there must not be any overlap in the categories. So again, nominal variables are things that you can't assign a numeric value to. Eye color, left-hand, right-handed, gender, sex, race, those kind of things. There's no number value there. Ordinal. These are ranked ordered. And what an ordinal level of measurement is, it's kind of like hot or cold. That's the best way to describe it. You're getting hotter, you're getting hotter, you're getting colder, you're getting colder. There's like you understand that there is a numeric value and there is a magnitude to the word itself, right? But there is no distinct measurement. In other words, example on this is social class, working, middle, upper. Opinions on the survey, and here's a big one you'll run into all the time, is agree or disagree, no opinion. So like when you see surveys like strongly disagree, disagree, neither agree nor disagree, agree, and strongly agree. Those are ranked ordered, and they have differing magnitudes, but there's no defined set distance between those magnitudes. The charts at a doctor's office that say how bad does this hurt, the pain level is 0 through 10, but there's no distinct values on like what a 5 is compared to what a 7 is, because those are based on feeling, right? Because a person's pain tolerance is different from one person to another. So one person's 9 is going to be different than another person's 7, for example. So ordinal variables are ranked, but there's distance between them, but they can't really be discerned, which moves us into interval. An interval is basically it's just a number. Okay, these are just distinct real numbers. They have equal measurements between them. In other words, the number 1 and the number 2 have the same distance between them as the number 3 and the number 4. Same deal with 5 and 6. There's an equal distance between those numbers. which means they are very discernible in magnitude. They're very defined in magnitude. So, $1 and is $1 less than $2 kind of deal. And you can say things, and you can do mathematical equations with interval numbers. So, intervals include income, temperature, and then temperature gets into ratio, and we'll get into that. But those kind of things. And then when you get into ratio variables, these are the interval variable, except there's a 0 point under, and this is like the highest level of measurement. So interval and ratio. So ratio numbers, you start running into things like conversions, such as degrees in Celsius. Same thing, but different measurements. Converting degrees of Celsius means there's no equal distance point, like in the number 1 to number 2 example. Uh, and it kind of works on that. So those are the 4 level measurements. Uh, you're going to be mostly working with nominal, ordinal, and interval in here. So make sure you know these for sure. You need to understand the difference between these three. If you have any questions, please email me. That concludes today's lecture. Thank you.